If you're in the electric utility space, then not only have you undoubtedly heard about Open Access Technology International, better known as OATI, but given that over 98% of energy organizations in North America use their software, you're also extremely likely to be one of the clients of theirs in some capacity. That penetration is the reason that the organization has been referred to as the operating system for the North American power grid as a whole. But it's their connection to the past and future of the entire sector that we wanted to better explore and understand in the lead up to DTEC, where they're going to be showcasing this incredible connection to the industry in the present, as well as new products like OATI Genie. And there's literally no one better to talk through these developments than a person who has driven it all, and that's OATI CEO, Dr. Sasan Mokhtari. So, Dr. Mokhtari, we know you're an incredibly busy person, so we really appreciate you taking the time to connect.
Pleasure. Thank you for having me.
So, OETI's history with AI is connected to your purposeful engineering approach that views the technology as a means to solve a problem rather than an end in of itself. So, can you talk a little bit about how this problem-solving focus has allowed you to avoid platform implementation challenges that other providers can struggle with? And what can you say about how this approach better enables you to support interoperability between systems?
Yeah, good question, Jeremiah. Thank you. I appreciate the opportunity again. It's a pleasure to be here. Good question you're asking. Um, I think before I talk about the AI, let me give you a little bit of background that I have and some of the people who came with me, and perhaps that helps give you the context of where we are heading with this. Um, I'm coming from a research and development background myself. And I'm used to working on new concept, new ideas, and bring it to the point that can be used in practice. That's what I did before I started OATI, and that has been my philosophy since then. So I approach this kind of new development um, in three steps. And that's the way we have always done at OATI. And if you look at all of our applications, pretty much I follow the same path. Um, Step one for us has always been strong R&D. R&D is the core tenant of one of the core tenants of OATI. So we have a very strong R&D program that we do new development um, every year. It's every year program. In one year we may have up to 17 to 19 new development activities going on, depending on some regulatory mandates or some new technology. And we use this as a way to prove the concept. This is not where we develop the product. That's just to demonstrate that it makes sense to do certain things or using new technology or proof of concept. That's the step one for us. Step two is working with customer to bring it to the next level, which is we call it MVP, most valuable product. That's where you develop the core product. That's where you work with the customer very closely, cooperatively, use a lot of agile development. So that's where customers bring their input into it to make sure whatever we do matches the business process. That's the second step. And the third step is we continue to work with the customer to turn this into a real product that can withstand the real life scrutiny and test. So by the time we get to the third step, it's almost guaranteed the product will work as supposed to do. So this has been our approach from day one. That's what we did with DERMS. That's what we did with our flagship tagging and OSs, as well as our trading system. So that's our approach.
Well,
Now
and
AI is not any different. Please.
no, that's what I was going to say is how AI is. It's not AI for AI's sake, and I think
Yeah,
that's an important
that,
distinction.
that, that's correct. You're absolutely right. And we don't apply technology for the sake of technology. Technology has to match the problem you're trying to solve. Absolutely. And so AI for us started as a matter of fact, my PhD thesis was AI related more than 45 years ago. So I'm very familiar with it. I was kind of rusty. It took me a while to come up to speed. The advancement in technology and AI is astonishing, especially the new type of generative AI, agentic generative AI, which goes way beyond the predictive AI that used for forecasting stuff like that. Has been around for a long time. Um, so that caught my attention about 5 years ago. That's where we started the actual development. So that was my phase one. Um, and then since then, I think we have been lucky to move to other phases. We have a major activity going on with one of our major customers to go to the next level and bring it to life in actual operation data centers. And our focus is really generative agentic AI, which does use LLMs, but also use agents, which that's what really gives it to the next level. And we are working really collaborative with customer. AI, the kind of AI we are talking about is not your typical AI or any other applications where you can use traditional software development like um, waterfall methodology. You really have to use agile. You really have to work with customer from the beginning. You really have to get all the stakeholders input because you're capturing the knowledge. It's not something that people can put on paper. If it was that easy, you would have used traditional programming. So that's the way we do AI. That's why I'm confident in our ability to come up with a tool which is ultimately going to be used by customers. So
It goes back to that practical application, and some of that foresight that you have around that is connected to what you talked about with the power grid today being upside down with so many new players and uncertainty really changing the paradigm. How is your technical baseline allows utilities to better manage this chaos without rebuilding their entire infrastructure from scratch? How are you able to
yeah,
to work with utilities
yeah,
to not to kind of meet them where they're at?
yeah, yeah. Interesting question, Jeremiah. It's a I the way we approach problems is as you seem to be suggesting is from engineering perspective. Our approach is not necessarily just develop a program or application for the sake of program and use the latest technology. Our approach is create something which can be utilized and can solve a problem for a customer. And we go for bigger problems to solve. And that has been our strategy from day one. I mean, this AI approach is not any different, except that it brings to the next level because of the complexity involved. So our approach is, look at the problem as you know, evolutionary problem, not revolutionary. We're not here to throw out what exists. This power grid has been in place for what, over 140 years. There's so much software has been developed. So many processes has been in place. You cannot just throw it out over a few years. So if we can just add software to it to meet today's need at the same time utilize what investment has been made in the past, that's what we do. um, so our tools, for example, our derms is designed to utilize the existing system to the extent possible. Just to give an example, how can I utilize the new DR, such as battery and maybe battery and solar paired, to defer capital investment, by using these devices on a substation. How can I use the software technology to squeeze more out of my existing system by rather than using a static, limitations on the particular critical points in the network like feeders, by adjusting it based on the real-time information. How can I monetize it? From utility perspective, they need to have ways to monetize these DERs. After all, they are there to make money. Um, so this is the kind of practical tools that we are developing.
And it ties into something that I know you talked about in the context of DTech about flexibility no longer being optional, and it's really the operating principle of this modern grid. So now is that flexibility in terms of practice or in principle? How is that flexibility something that you have top of mind?
When I talked about that, I'm looking at practical aspect of this. We are used to power grid, which was designed and built to be very, very robust. So, and the way this was done is, you make sure you have uh, a lot of margin, in terms of system capabilities and capacity. So, system were designed based on offline studies and based on the worst case scenarios. So there was a lot of room for error. So what if I miss something? There is enough, inertia in there to absorb it. Well, today it's changing. Today, the power grid is not quite as predictable. I cannot predict my load as good as I did in the past. As a matter of fact, as a utility, I don't have control over all the generation because some of it is owned by other people, whether it's behind the meter, in front of the meter. I don't have even total visibility to it. So the whole nature of the grid has changed. It's very dynamic and it's constantly changing. It's not, I cannot rely on offline studies. So you have to rely on real-time analysis to figure out, what's the situation with the system, what are the bottlenecks, what can I do to resolve it. So we are dealing with a very dynamic system. So that's what I mean when I was talking about, we have to, system is very now flexible, and you need to be able to utilize this flexibility to the extent possible.
Well, I mean it's complicated, and we say utilities in shorthand, but there's so many different pieces and parts and silos and segments. So what's the importance of your solution being a bridge between bulk power and distribution operations that help utilities manage the grid from meters to markets? How much money are utilities leaving on the table because their distribution side isn't talking to the trading or market side?
Yeah, yeah, that's a good point here again. Uh, I had a talk many years ago. It must have been 15 years ago. I gave a presentation to a group of utility professionals. Back then, I discussed the same issue that, this what's happening now, in terms of what was I perceive is going to happen, which is happening now, is utilities are going to lose, a lot of load because now they're generated locally, whether it's by solar panel on the roof or other means. And it's so important for utilities to find a way to get engaged and uh, and utilize these resources and find a way to monetize it. At the same time, use it for reliability purposes. And I'm so thrilled to see after all these years, it's finally happening. Things are moving very quickly, and people, utilities and others, they have accepted that this is no way that the grid is going to work. Call it modernization of the grid. Um, if you think of it from transmission wholesale perspective, they are losing generation. Generators are retiring, so some of that is lost. And there are not new generations, being financed. So they still need to have access to generation in order to balance the load and generation, which is the foundation of the power grid, reliable power grid operation. They need grid services in order to make sure, there is the frequency is maintained and the voltage level is maintained and reserve is maintained. So they need all these, resources. Well, they have to go to distribution and get it from distribution. Now they don't have visibility over distribution, as much as they did when they were in charge of the generation. And at the same time, they don't have control over it the way they did. Now the entity that comes in the middle that helps them with this visibility, with this some level of assurance that they will get what they want, is your DSO, the distribution system operator, which sits between distribution and transmission. So it's a bridge that, you know, allows the process to vet the resources available in the distribution to support transmission. Now, at the same time, resources in distribution, they have valuable commodity. They want to offer it to the market. So again, DSO can accommodate this the reverse, interaction. So, so the point is that the boundary between transmission and distribution is not as clear cut as it was 5 years ago, 10 years ago. It's now blurry.
And all of that goes into what we've been talking about with that transformation of the grid into this dynamic, flexible system. What do you think is the biggest technical hurdle in terms of transitioning from what's more rigid mindset to a dynamic one that it needs to be?
This new regime of power grid operation has multiple complexities. And then I'll tell you which one I think is probably could be the most challenging one. Um, you know, um, we used to have the utilities had finite number of big generators that they had full control over. Now they don't have that anymore. They have to rely on a lot of smaller generation assets that they are distributed everywhere. Some transmission, but mostly distribution and some behind meter and front meter. So that's a challenge. How do I deal with this very diverse event, variable generation that I don't even have control over? There are many integration points. The number of integration points in the old regime was relatively small, a few, maybe half a dozen, maybe a little bit more, maybe 8. Today, you're dealing with, dozens and dozens of interfaces that a lot of data will come into these systems. So these interfaces could become, weak points, because if I'm using for reliability and I'm counting on this, and interface is, I can't talk to these assets, is problematic. One of the biggest challenges is uncertainty. They are uncertain on what is the load. The load can become a generation in a flash, and consumer can become a prosumer. At the same time, they don't even have much certainty in generation. So generation that used to they can rely on now, they don't even know it's available, or the cloud comes in and all of a sudden you don't have solar, or the wind stops blowing, or you rely on the thermostat, of a customer to change it, the temperature, and they decided not to. So these are all really, to me, very serious concerns that utilities have, which I believe, we have come up with solutions, and over time you get better and better. So, but to me, probably if I were a utility, my biggest concern would be, I want to have control over my resources. I want to know when I can generate. I want to know, when I can increase my generation, decrease generation. This is something that I would have thought about it as a utility. Yeah, so I need some sort of assurance. When I ask for something, I get it. Otherwise, I will have a blackout or I will have other issues. Again, there are solutions to these, and you'll get even better and better in time.
Yeah, I think it goes back to a sense of awareness that we know is out there and possible, but it's about connecting those dots. What can you say about what it means for you to connect those dots at DTEC?
The grid modernization and changes happening, Jamar, is substantial. Nobody can question it. That's probably the biggest change has happened, in my opinion, since the inception of the grid. We all went through, FERC order 888, 889, the open access in wholesale. That was, to me, that was, at that time, it looked like, wow, that's a big change. The changes happening now is much more, in my opinion, significant than that change. And the reason is that with these new changes, not only operational procedures and perhaps some, operational, steps are changing, but also the kind of infrastructure is changing. The grid was designed to be one way. The flow of energy was supposed to be one way. It's supposed to come from top to the bottom, from generation, transmission, all the way to load. Now it's changed. Now it's going both directions. That's a big change. That's a big change. The first step was DERMS, and it was a little bit rocky at the beginning, but today I believe that people are on board. We are astonished with the number of requests from customers for DERMS. But to me, it has its own problem. The problem is that now the utility operators, they are dealing with tremendous amount of information. They're getting overloaded with information that they have to go through, and they have to manage. And that's becoming very challenging for them. The systems are not quite they don't have as much margin as they had for errors and mistakes. So there's tremendous amount of pressure on the utilities and ISOs to deal with this new system that has a lot of information, a lot of integration points, a lot of new players they have to interact with, and so forth. So firms they will need help. And to me, AI is a companion to DERMS. They go hand in hand. And again, with AI, I mean AI as an operator assistant. And of course, AI has its own place as a predictive forecasting tool. But as an AI assistant to assist operators with, to do some of the mundane workflow activities, as an assistant to consult with, as an advisor, I have a question. I have, tell me more about this procedure. I have this problem. How do you recommend to solve it? If I can capture the knowledge of some of the SMEs and the utilities in this AI, then it becomes available to all the operators. AI can be used as a reconnaissance type tool agent. They can monitor alarms. They can monitor system conditions. If they see something bad is happening, notify the user. They can look into more insight into information and provide information that operator may not even know of. And ultimately, they can become autonomous, with the human in the loop, with the man in the loop. So to me, the future lies in AI deep into every, control center, every utility, along with all the tools.
Well, AI is a tool rather than an end unto itself, and it just feels like that's a very important distinction. Well, Dr. Mokhtari, I really appreciate you taking the time to connect. Last question I have for you. We've been talking about power, about the utility industry. So tell us something powerful.
There are many challenges. A few years ago when the DERMS came about, there was disbelief. I remember those days that when first time about 15 years ago, we were talking about this with our customer base, and they were just looking at it. It's not going to happen. This is too far-fetched. It's too risky. Today is happening. Today is happening. I think our philosophy at OATI has been, make the impossible possible. Things that they look out of reach, impossible. It's not. It has been my philosophy all my life, and it doesn't just apply to work. It isn't in your life. Once you put your mind and your heart into almost anything, you can achieve it. And I think that has been. If you go to OATI, you will see that we have a theme written on the walls: make the impossible possible, and that's the attitude. I believe we can do it. I believe. The new systems will work. We are changing something that took over a century to build. We are trying to change it, put it on its head. in a matter of few years, and that's a very challenging job, but that's doable. So once you put your heart and soul into something, you can achieve it.
That is indeed powerful. Well, really appreciate you taking the time to connect today, and looking forward to catching up with you and your entire team at DTech in February.
My pleasure. Thank you so much. You have a good day.